Greetings everyone, and welcome to the next video in my lecture series on differential equations. We are still working on Laplace transforms, and in this video we solve an initial value problem using Laplace. So you can see that our example is we're going to solve 2 dy dt plus y is equal to 0 if y of 0 is equal to negative 3. Now we've solved this type of differential equation before. It's separable. It's also linear first order, but now we're going to solve this using Laplace transforms. So let's begin. For our answer, the first thing is we take our Laplace transform of the derivative. So we're going to take 2, and then in brackets, we're going to write down s, y of s minus y of 0. So recall that we're actually taking the Laplace transform of dy dt. The Laplace transform of derivative is s times the Laplace transform of the function itself, not the derivative, minus the value of the function at t is equal to 0. So the dy dt gives us this entire term here. And then we're going to add to it the Laplace transform of y, which is just capital Y of s. And the Laplace transform of the right-hand side just gives us 0. So multiplying out, we get 2s y of s. And then putting in the y of 0 is equal to 2 times negative 3 plus y of s. Oh, sorry, that should be a negative sign there. So 2s y of s minus 2 times the value of y equals 0 is equal to negative 3. Recalling here that that's our initial value. Let me not try to write with my highlighter pen. And we get 0. And so we get 2s y of s plus y of s plus 6 is equal to 0. So moving the 6 to the other side gives us negative 6. Then factoring out the y of s gives us 2s plus 1 y of s is equal to negative 6. So y of s is equal to negative 6 over 2s plus 1. And now we have to take the right-hand side and make it into a form that looks exactly like one of the entries in our Laplace transforms table. So what we really want is s plus something, so I'm going to factor out a 2. I get s plus a half here. I'm going to stick the negative 6 out in front as well. So I've pulled a 2 out of the denominator. I'm pulling the negative 6 out front. So that just gives us negative 3 over 1 onto 1 over s plus a half. And so taking the Laplace, inverse Laplace transform of both sides, I get y of t is equal to negative 3 e to the negative t over 2. And that's our answer. Notice the beauty of this approach, which is if we had taken a linear first order, we would have had to calculate an integrating factor, find the general form of the solution, then put our initial value back in. We would have had to be careful about all of that, and this is actually just a lot faster. Whether or not you like it depends on your familiarity and ease with Laplace transforms, but here you have it.